Hello, Algebra 1. Today we're looking at section 3.1, graphing linear inequalities in two variables. And this is a difference. We have graphed inequalities, but there was only one variable, so we put those on a number line. But now that there's two variables, we're going to be graphing them on a coordinate plane, so it's kind of different rules, a little bit different rules. Well, first things first, if we're talking about an inequality, we're going to have all the different inequality symbols as possibilities. Part of doing this is we're going to have to do test points. And so we're going to have to check if things are a solution. Also, it's just good practice to be able to tell if something's a solution of an inequality or an equation. So that's what we're going to practice first. Tell whether the ordered pair 2, -2 is a solution of the following. Well, remember, x, y. And we're just going to substitute them in. And I'm really careful about substituting them in very carefully. I want to make sure I've got all my signs represented, didn't drop anything. From there, I do PEMDAs, or order of operations, and I go kind of quick with this. So I know that I'm going to multiply these together first, and that'll get me 6. And then I'm going to add the 2, because what's going to be left over is 2 plus 6. So I usually do that in my head, and 2 plus 6 is 8. And I'm left with 8 is greater than 8. Well, class, that's false. That's not true. 8 is equal to 8. It's not greater than 8. So it's false. So was it a solution to this inequality? No, it was not. Let's move on to the second one. Again, I'm really careful about inserting the values and making sure I've got all the negative signs. And I'm realizing something. This is going to be the exact same answer because it's the exact same expression. But my inequality symbol is different. So on this one, I'm going to get 8 is greater than or equal to 8. Now, class, I have some students say, no, that's not true because it's not both. It's not both equal to and greater than. Well, class, that would be an impossibility. You can't be equal to something and greater than it if you're a single number. So you're one or the other. You can be greater than or you could be equal to. And on this one, it's going to be equal to 8. So this is true. And so we would say, yes, it is a solution. 2, -2 was a solution to that inequality. And then we've got a plain old equation here, and I'm going to just cheat and go to the end because it's the same expression. So we're going to get 8 on this side. We're going to get equal to 8, and by golly, that's true. So we will say, yes, it is a solution to that equation. Okay. Well, class, to graph linear inequalities in two variables, you're basically going to graph the line that's associated with the inequality. Typically, we'll get y by itself to get it into slope-intercept form, y-intercept of 0, up 2 over 1, up 2 over 1. But we don't just graph a line. This is a boundary line. It's going to be a boundary line between solutions and non-solutions. And because it's less than, we can't be on the line. So what we do is we do dashes. When we were doing strictly number lines, we would do circles. We can't be the number. In this case, we can't be the line, but it says it needs to be less than 2x. Well, we're talking about y. Y values, or the y needs to be less than 2x. So I know that you would shade below. But before you realize that, or if you don't have y by itself, you're going to want to use a test point. It turns out a good test point is, I don't know, I often use 0, 0, but because it's on the boundary line, I can't use that. So let's use 0, 2. And what we do is we test it. We plug in 0 for x and 2 for y. And that's going to get us 2 is less than 0. And class, is 2 less than 0? No, it is not. That's why they shaded on the other side. When you do a test point, if it's true, you shade that side. If it's false, you shade the other side. So that's how they got the shading there. So they kind of summarize the steps here on how you're going to do this. So you can take a look at that. Yep, use a dashed line for less than or greater than. Use a solid line for less than or equal to or greater than or equal to. Use a test point to determine which side of the boundary line to shade. Yeah, and if it is a solution, you shade that side. If it's not a solution, you shade the other side. But also, I'm going to kind of help you realize if you have y by itself, it's pretty straightforward to tell which side to graph if you just kind of think about it. All right, let's flip it over and take a look. Graphing a linear inequality in one variable. Now, technically, we're still doing two variables. It just so happens that we don't have an x variable, but we're still going to graph it on a coordinate plane that has an x and a y. So that's a bit of a misnomer there. So we're going to graph y is less than 2 in a coordinate plane. Well, you might recall from previously that if it's y and there's no x, it's going to be a horizontal line. Well, if you forget that, just kind of, if you're ever like, oh, I can't remember if it's vertical or horizontal, think about a number, a table of values. Y has to be 2 no matter what x is. And if you plot those points, -3 up to 0 up to 1 up to, you quickly realize, oh yeah, this is going to be horizontal. I have that committed to memory. You should have that committed to memory from our last chapter, but you can always do a table to figure it out. Now, I got a little bit ahead of myself. I made a solid line. Was that accurate? Because it was equal to, that is accurate. It would be solid. Our boundary line would be solid. And then, class, I know we're going to shade below because it says y less than 2. Well, less than 2 is going to be below the 2, y values of 2. So anyway, I know we're going to shade below, but we can also use a test point. And this time I do get to use 0, 0. So I'm going to use a test point real quick. Since there's no x, I just put in 0 for y, and I get 0 is less than or equal to 2. Well, that's actually true. So we get to shade on that side of the border line. And that's our graph right there. Pretty cool, huh? Now, if we've got two variables, you've got some choices here. You could graph this by using intercepts. And if you do that, you are most definitely going to have to use a test point because you don't really know what, if it's going to be above the y or below the y. You don't know that. So if you were to graph this using intercepts, you would get the x-intercept, the y-intercept. And for the x-intercept, you put 0 in for y. And we're going to be done pretty quick here. We're going to get negative x is greater than 2. X isn't by itself yet. We divide by a -1. Oh, and this is good. This reminds us, when we divide both sides by a negative of an inequality, it flips the relationship. On the number line, everything is in different places on the number line. So we have to flip that. For the y-intercept, we put 0 in for x. Whoops, that's going to be a big fat 0. Plus 2y, and yes, we get 2y is greater than 2. Divide, and we get y is, y is greater than 1. So it's a little bit of, I probably shouldn't have put the inequality symbols, I'll be honest, because I'm just graphing points here. I'm graphing the x-intercept at -2, the y-intercept at 1. So it's a little bit, I really didn't need the inequality symbols here when I'm finding x-intercepts and y-intercepts, so that was kind of silly of me. But we do notice it's going to be no equal sign, so it's going to be dashed. It's going to be dashed. And then we do a test point to find out which side we shade. I don't have y by itself here, so I can't really tell right away. So a test point, I'm going to use 0, 0 because it's on one side. If I put zeros in, I'm going to get 0 is greater than 2. Class, is 0 greater than 2? False. So we're going to shade the other side. We're going to shade up. Okay? So that's graphing it using intercepts. We could also graph inequalities by using slope-intercept form. So this is similar. Actually, this is an equation, but let's graph this using slope-intercept form. So to do slope-intercept form, we'll add the x over. We'll get 2y equals x plus 2. Divide everything by 2. Divide everything by 2. We'll get y is equal to 1/2 x plus 1. And here's our 1, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, back 1, or down 1, back 2, down 1, back 2, down 1, back 2. And again, well, check, it's an equal sign, so we're going to do solid line and no shading because it's an equation. So that's kind of interesting. Okay, probably most of the time you'll do slope-intercept form to graph, but I just wanted to do an example of using the intercepts to graph as well. All right, down here we've got an application problem. You've got at most $10 to spend on grapes and apples for a fruit salad. Grapes cost $2.50 per pound, apples cost $1 per pound. They want us to write and graph an inequality that represents the amounts of grapes and apples you can buy. And then they also want us to identify and interpret 2 possible solutions of the inequality. Okay, so class, we've got 2 unknowns here. We need amounts of grapes, we need amount of apples. So I just arbitrarily made grapes x and apples y. And then we have that it needs to be at most 10. So that translates to less than or equal to 10. The amount of money that we spend needs to be less than or equal to 10. Now here's the thing, we don't know how many pounds of grapes to get, but we do know that $2.50 per pound. So it's gonna be $2.50 times however many pounds of grapes we get. Our total is gonna be added, we're gonna add to our total $1 for every pound of apples. And that's my equation right there. The total cost needs to be less than or equal to 10, at most 10. But we've got 2 unknowns here, so we can't just solve for x and be done. Instead, we're gonna graph the possible solutions, which is pretty cool. I'm just gonna subtract that 2.5 over, and I'm gonna be ready to graph this. So yeah, I've got a y-intercept at 10. 6, 7, 8, 9, 10. And then we use our slope down 2.5 over 1, down 2.5 over 1, down 2.5 over 1, down 2.5 over 1, and then we connect them. Solid line because we've got it equal to. And then class, think about this. We're not going to extend out our line at all because it wouldn't make sense to buy negative pounds of fruit. That wouldn't make a lot of sense. So we're going to stop at our x and y axes, but we can buy anything less than that or equal to it. So some possible solutions would be anything in this shaded area or anything on the line. If it was a dashed line, we couldn't be on the dashed line because it's not a solution. But since it's solid, we can be anything on the solid line. We can be in the shaded area. So yeah, just a couple of examples. I'm just going to put some points in there. But this would represent buying 2 pounds of grapes and 1 pound of apples. That's a possibility. This point right here is 1 pound of grapes and 4 pounds of apples. But if you can see, there's lots of different possibilities here. If you want to spend all your money, you got to be on the line. Thanks for watching.